All right, well, hello and welcome back to the Intermediate Algebra Final Exam Review Series. This is Joe Brownlee with Palm Beach State College. We are on question number 24, so let's jump right in. All right, the directions for number 24 are use the quadratic formula to to find the complex solutions of the given equation. All right, so 24. And the equation they give us is 5x squared minus 7x plus 8 equals 0. All right, well, you may recall, if they want us to use the quadratic formula, then the quadratic formula is going to be x equals negative b plus and minus the square root of b squared minus 4ac divided by 2a. All right. Now, it's important that before we actually start the process of solving using the quadratic formula, that we make sure our given equation is in a particular form. And that form is going to be ax squared plus bx plus c equals 0. And the reason we want it in this form is so that we can easily identify our a, b, and c, because of course we're just going to be plugging in those values into the quadratic formula and solving. So this is really a plug and chug type of question. And so I can see that my given equation is set to 0, which is what I want it to be, and so I'm able to easily identify my a, b, and c. And so a is just the coefficient of my x squared term, and in this case that's just a 5. My b is the coefficient of my x term, which in this case is a negative 7. And my c is my constant, in this case just a positive 8. And so now that I've identified a, b, and c, let's go ahead and plug them in and see what happens. So x equals, and I would beg you, when you are using the quadratic formula, really anytime you're plugging in values for variables, please use parentheses, because with some of these negatives, especially with the plus and minus here in front of the radical, sometimes things can get a little hairy. So just if you plug in with parentheses, I think it'll save you a lot of trouble down the road. All right, so x equals negative 7 plus and minus the square root of negative 7 squared minus 4ac divided by 2 times 5. All right, well, let's go ahead and start to simplify. So this is x equals, when I distribute my negative to my negative 7, a negative times a negative is a positive, so this just becomes positive 7, plus and minus the square root. Well, let's see, what is negative 7 squared? Well, that's going to be a positive 49. And then I have 5 times 8, well, that gives me 40. And 40 times negative 4 gives me a, well, 4, 8, 12, 16, gives me a negative 160. Divided by 2 times 5 is 10. But let's go ahead and simplify once again. So x equals 7 plus and minus the square root. Well, 49 minus 160 is negative 111 divided by 10. All right, go ahead and section this off here. Well, we can rewrite the radical, can't we, like this. This is really the same as 111 times negative 1, isn't it? And so we know that we can't have a negative under an even indexed radical. And so when I write or rewrite my radical as a positive 111 times a negative 1, it helps me to see that I know I'm going to be pulling out an I from that negative 1. And so really, when we rewrite this for the last time, we're going to get x equals 7 plus and minus. My I comes out. Radical 111 divided by 10. Now, if I could break down 111 into good stuff, bad stuff, I would, but there is unfortunately nothing good in 111 when it comes to the index of 2, and so it is all garbage, so to speak, and so all of it stays under the radical. But again, when we rewrote it as 111 times negative 1, we know the square root of negative 1 is I, and so we could pull out the I. And then we put that all over our denominator of 10, and this is it. So that's my final answer. So that is how we use the quadratic formula, x equals negative b plus and minus the square root of b squared minus 4ac divided by 2a to solve a quadratic equation. Now, it's important to note that you can use the quadratic equation to solve any trinomial, to factor any trinomial. So all of those trinomials that you try to scissor but you can't, you try to complete the square but you can't, all of those can easily be solved using the quadratic equation every time, so long as you set your equation equal to 0 and make sure that your leading coefficient of the x squared is positive. Alright, so this was question number 24. We're moving right along. We're going to go to question number 25, which is the halfway point. Again, this was Joe Brownlee with Palm Beach State. Thanks for watching.